everyone. I, Suvarna Mujumdar, Assistant Professor in Electronics and Communication Department of Ajay Kumar Garg Engineering College, welcomes you on a lecture on 8086 pin diagram. In earlier lecture, we have discussed about the architecture of 8086. We have discussed that there are two types, the architecture is divided into two blocks, bus interface unit and execution unit. And these two units work simultaneously so that it can speed up the operation of 8086. The bus interface unit is used to interface the microprocessor with memory or input output device, that is it will fetch the data from memory or input output device, and execution unit is used to execute the data which is fetched from the memory. So these two tasks is done simultaneously in 8086, and also in 8086 we have discussed about the segmentation, that we are using total memory, that is 1 megabyte memory, we divided into a segments, 16 segments, each of 64 kilobytes, and we at a time 8086 can access 4 segments, and the starting address of these segments are stored in the segment register, which is there are 4 segment register: code segment, data segment, stack segment, and extra segment. We had also discussed about the register organization of 8086, and we have seen that there are two types, broadly if we classify, there are two types of registers, general purpose registers and special purpose registers. There are 4 general purpose registers, each of 16 bit, and we can further use them as an 8-bit registers also. And the special function registers are also, special registers are further classified as pointer and index register, segment register, and control and status register. So in earlier lecture we have discussed about this. Now in this particular lecture, I am going to discuss about the hardware, or you can say the pin diagram of 8086 and all the pin details, that how this 8086 IC will work. So as we will see, it is a 40 pin IC, total 40 pin IC. Okay. So we have to discuss all these pins one by one. This total 40 ICs are divided into 3 groups, or you can say we can have more, we can work, we can use 8086 in 2 operation mode. One is minimum mode and maximum mode, as I have written here. So when we are using 8086 in minimum mode, then pin number 24 to 31 are behaving like the name given here, this part. Okay. And if pin number 24 to 31, if we are working 8086 in maximum mode, then these pins are working in different mode. Other pins are common in both the modes. So we can say there are 3 group we can classify our 8086 pin structure. One is common signal, another one is minimum mode signals, and third one is the maximum mode signal. Now how we are going to define that when 8086 is working is minimum mode or in maximum mode? So for that we are having this 33 pin. If this 33 pin is connected to plus 5 volt supply, means if this pin is connected to plus 5 volt, then this 8086 pin, this 8086 IC is working in minimum mode. And if this pin is connected to ground, that is MX dash bar, so it is using as in a maximum mode. Okay. So in minimum mode, these 24 to 31 pins are behaving like the name given, a hold, HLDA, write, M/IO bar, DTR. We will see one by one what this pin signifies. And in case of maximum mode, that if we connected this pin number 33 to ground, then these pins are active as a QS1, QS0, S0, S1, S2, that these are status signal, lock, request and grant signal. So these are working in maximum mode pins. Rest are common in both the modes. Okay. So we will see one by one. So first we will see the common signal, then we will go with minimum signal, and then we are going with maximum mode signals. So first of all, there are 2 grounds are available here. One VCC and one clock. So clock here is an 33% duty cycle. 8086 is working with a clock which is having 33% duty cycle. It is not working with 50% duty cycle. VCC plus 5 volt and plus minus 10% is the tolerance. Then reset signal. If we have to reset the system, we have to restart our 8086 microprocessor, then in that case this hardware pin is used, and the register, segment register, the flag register, what will be the content? So the content of code segment after resetting, the code segment will be having FFF value and IP is having 000H. And if when will this happen? It happens only when this reset pin is high for minimum 4 clock cycle. Okay, then only the system get reset. So mostly we are using in our laptop, we are having an hardware reset button. We press that button and our system get rebooting. So that pin, that push button is connected at this pin in case of 8086. Now, the most important things which is required for microprocessor to communicate with outside world is the address lines. So, as we discussed earlier also in features of 8086, that there are 16 data lines and 20 address lines. So, the 16 data lines are multiplexed. You can see here these AD0 from pin number 16 to AD14 here to and 39. So, these 16 pins are multiplexed, means these pins at a time work as an address line, and for another clock it will work as a data line. Why we are going for multiplexing of address and data lines? And in case of 8086, you also see there are many more signals which are multiplexed, like 24 to 31. These pins are also having dual working. Means here you can see from 33 to 38, all these pins are dual in nature. They are working dual. At one time they are working as another operation, and second time they were working as different. So this multiplexing is done so that we can miniaturize the system. If we go with 16 different address line and 20 different address lines and 16 data lines, then in that case our number of pins get increased. So miniaturization, to make the system compact, we go with multiplexing. But as you know that for a particular time we want address should be there on that particular line, but for second time we want data should be there. So we need to demultiplex it. Okay. So for demultiplexing, here these lines are multiplexed, and when we are going for demultiplexing, we have to use ALE, address latch enable. Okay, this ALE signal, that is pin number 25. This ALE signal is used to demultiplexed address and data lines. Whenever microprocessors start communication, the first clock cycle, for every first clock cycle in any instruction, first clock cycle, the data, or you can say the operand which is traveled, or the value which is traveling on this address, this AD lines, that is pin number 16 to 2 and 39. On this line are the address. Now this address get latched in a latch system. So how it is going to latch? For activation of that latch device, latch is an hardware, and to activate this latch we use this ALE signal. We make this ALE signal high in the first clock cycle, and we will microprocessor proceed with the address on the address bus. Now the latch device will latch this address for further communication, and then it get free the data lines to carry the data on it. Okay, the remaining 4 lines, higher order address lines, these are also multiplexed with status signal. Okay, so sometime it is carrying the address, and for other time we can use it to show the status. So A16 to A19 carries the address line, means pin number 35 to pin number 38 are carrying the address, as well as they are having the status. So what status they are showing? This pin number S6, that is the pin number 35, it is always logic 0. Pin number 36, that is S5, it indicates the condition of IF flag. IF flag is interrupt flag. We have seen this in flag register. This flag is used if this flag is 1, then only the interrupt can ask for service routine to be executed by 8086. If this bit is 0, then no interrupt can be serviced by 8086. Now, pin status line S3 and S4, these indicates the which segment currently is working, means microprocessor is working with which segment. There are 4 segments: code segments, data segments, stack segment and extra segment. So, the address lines carry which data, which address. For stack segment or current code segments, means microprocessor is working with which part of memory. So, if S3 and S4, if S3 and S4 is 00, it indicates that microprocessor 8086 is working with extra segment. Whatever address is traveling on address bus, that address is for extra segment. If it is 10, then it is code segment. Okay, the where we had written our program. And 11 data segment, and if microprocessor is working with stack segment, that is our temporary storage location, S4 and S3 is having 01 value. Now next, BHE bar and S7. This line is again used for demultiplexing. This is known as bus high enable. This line is enable and most significant data bits, that is D8 and D15 are demultiplexed from address lines. Actually, we have two, we are having our data lines are 16 bits. So, we need 2 latch, 8 bit each. Okay. So, AD0 to AD7. To demultiplex this, we need ALE, we use ALE, and to demultiplex AD8 to AD15, we use BHE bar, that is bus high enable active low signal. This bar sign indicates this is active low signal, that when 0 is traveling on this, then only the latch get activated and it can separate the data lines from address lines. And this BHE signal is having one more application, that actually our memory contains 8-bit data. In a memory, wherever we have a memory of 1 megabyte or 2 megabyte, at each register is of 8-bit. Okay. But microprocessor 8086 needs 16-bit data to process, as it is a 16-bit processor. So, in that case, microprocessor has to read consecutively 2 memory location, 8-bit each. Okay. So, so that it can have 16-bit data at a time. So, for that we use a concept of even and odd bank, and in that even and odd bank concept, we need BHE signal to be activated. Sorry, before this, I can erase the all. Yeah. So, this BHE signal and A0 signal. A0 is our address line, that is pin number 16. So, pin number 16 and pin number 34, the combination of these 2 pins will suggest that whether microprocessor is reading 16-bit at a time, or microprocessor is reading first high bit from odd address or low byte from even address, or there is no selection, means we are not selecting any memory location. So, if we are selecting low byte from even address, then in that case we are reading only 8-bit data at a time. If we are reading high byte from odd address, that is this case, then in that case our two cycles are there, one for even address data collection and another for odd address data collection. If we have to read a data in a one clock cycle, then in that case we use this type of arrangement, that we will read a first byte from even address, means our address should be even, means like 2000 or 2002, this will be our IP, content of IP. If our address is even, then only microprocessor can read 16-bit data in one go, that is in one cycle. Otherwise, it needs two cycle, one to read from even address and another to read from odd address. Okay. So, this BHE and A0 signal is used to differentiate between even and odd bank. Then there are two types of interrupts. One is non-maskable interrupt at pin number 17, NMI. It is working same as the trap, that whenever this interrupt occurs, microprocessor has to leave the current program and switch to the service routine related to non-maskable interrupt. This interrupt is not masked in our program. Next is INTR, that is interrupt request. So, this is our normal interrupt. We can mask this interrupt in our program. If we do not want this interrupt to be to disturb our main program, then we can mask this interrupt by making IF interrupt flag 0. Now, whenever interrupt occur, microprocessor has to acknowledge that interrupt and give a signal to the interrupt that okay, now I am going to serve the interrupt service routine. So, for that this INTA acknowledgement, interrupt acknowledgement pin is activated, that is pin number 24 is activated in response to the interrupt when microprocessor is ready to serve that interrupt service routine. Okay. And this is an active low signal, means pin number 24 carry 0 at the at 0 value, that is the output signal. Okay. Now, next is next we are dealing with hold and HLDA. Okay. So, hold and HLDA, these are the two pins or we can say pin number 30 and 31. In minimum mode, these two pins are used to interact with DMA, that is direct memory access controller. Whenever microprocessor or we can say whenever there are large amount of data to be transferred from input output devices to memory or from memory to input output devices, then in that case we use DMA, direct memory access, to communicate this operation. So, for that DMA gets a request from any input output device, and when DMA gets an request, it will send a signal, that is hold signal, to microprocessor. So, this pin number 31 is an input pin. It gets an hold signal, that is an interrupt signal, and when microprocessor is ready to release the control of bus, then it will generate this hold acknowledgement signal, that is output signal. When this HLDA signal is active, that is HLDA is 1, in that case DMA takes the control of buses, system bus, that is address bus, data bus and control bus, and microprocessor releases the control of bus to the DMA, and DMA will then transfer data directly from input output devices to memory. And when this operation gets completed, then buses control of buses is released by DMA and given back to the 8086. Now, some control signals. Read, that is an active low signal. Whenever microprocessor is performing some read operation, this 32 pin is active low, as 0, this is output pin, So 0 is here indicating that microprocessor is performing a read from either from memory or from input output devices. If microprocessor is writing something, okay, then in that case this pin number 29 is active. Again this is an output signal, and 0 as write bar, active low signal. So microprocessor, if microprocessor is reading, then in that case 32 pin is 0. If microprocessor is writing something, then in that case 29 pin is carrying 0 value. Okay. Now this pin number 28 M/IO, that is memory or IO. If this pin number 28 carries 0, sorry, if this pin number 28 carries 0, in that case IO slash bar. So IO bar. So IO bar means microprocessor is dealing with input output devices. Either it is reading from input output device or writing into input output device. If this bit is 1, 28 pin is 1, indicates that microprocessor is working with memory. Okay. DT slash R bar, data transmit or receive. Okay. So this data transmit or receive, whether microprocessor is transmitting some data or receiving this data. So if microprocessor is transmitting some data serially, then in that case pin number 27 is 1, indicating that microprocessor is transmitting some data. If microprocessor is receiving some data, then it indicates it is 0. It means microprocessor is receiving some data. And DEN, that is data enable. This data bus enable, this line is active low and it indicates that now data is available in data bus for output buffer. We have to enable that buffer. Okay. Now, in case of maximum mode, okay, these signals from 24 pin to 31 pin. Okay. The working, if I connected this 33 pin to ground 0 volt, then this 24 to 31 pins are working in a maximum mode. So in case of maximum mode, this pin number 26 to 28, that is S0, S1 and S2, these are the status signals and it is used to generate or we can say it is used to connect with 8288 processor to animate the maximum mode. So in case of maximum mode, these pins S2, S1 and S0, if these are 00, it means microprocessor is having an interrupt acknowledgement. Okay, if 001, it indicates that microprocessor is reading IO port. If it is 010, means microprocessor is writing into IO port. Halt, that no operation is, means now system is stopped and there is no operation, then in that case the status is 011. If microprocessor is accessing code from code segment, then it is written as 100. If it is reading from memory, 101, writing into memory, 110, and this is non-passive, means we are not performing any task. So status signal are used to indicate what operation is microprocessor is performing at that particular instant when we are reading this status signal. So these 3 pins are the output pins. Next, like in case of minimum mode, we have hold and HLDA. So that DMA can request microprocessor to take the control of buses. Now similarly, in case of maximum mode, we are not dealing with single processor. In case of maximum mode, there are more than one processor. So if there are more than one processor are working on a subsystem, then we need to have a control of buses. Okay. So then in that case, these 2 pins 30 and 31, that is request and grant. So these 2 pins are used to send a request and takes the control of buses. So suppose there are 2 processor, one is 80861 and 2, or you can say A or B. So the B processor, if A is a master one, then in that case master one will have a control of buses, system bus. It consists of address bus, data bus and control bus. whenever second microprocessor, B processor, wants the control of buses, it will send a request to this microprocessor, and if it is ready to grant the service, then it will release the control of buses to that particular processor, and that particular processor will complete the task and then release that bus control to the 8086 microprocessor. Next is lock. This lock is an output pin. It is used to lock the peripheral of the system. So, whenever microprocessor does not want to get interrupted from any slow peripheral device during its process, then in our main program or in our program module, we will write some locks instruction which will be used to lock the peripheral device so that it will not interfere the working of that particular 8086, means they can't ask for any request. Okay. So, for example, if microprocessor is performing some task and in between that task microprocessor does not wants to release the bus's control to another processor, then in that case it will lock the system so that no other processor can send a request to the microprocessor. QS0 and QS1. Q status. In case of 8086, we see in the architecture that there is an instruction queue, which is of 6 by 8. This instruction queue is used to store the prefetch opcodes or instructions. So, this queue status, what is the status of that particular queue if any programmer or anyone wants to see the data. So, by monitoring this pin number 24 and 25, we will see what is the status of queue. So, if this QS1 and QS0 are, if these two pins, pin number 24 and 25 are 0, then queue is idle, that there is no data in that queue. If ideal in the sense the 6 byte data is there, it is an idle situation. If first byte of opcode, if 01, it indicates that microprocessor is taking the first byte of opcode from the queue. 10 indicates that queue is empty, and 11 indicates that subsequent byte of opcode is going on, means consecutive operation is performing by the microprocessor. Okay. Next is this test signal. This test signal is used by microprocessor so that it can perform some servicing or you can say the operations related to 8086. Another signal is ready. It is also an input to the microprocessor and it is used by slow peripheral devices, means some peripheral devices which are connected with 8086, if they are working with slow, whether they are reading with slow frequency and they are not patch up with this 8086, then if this that peripheral devices make this pin high, indicating that microprocessor has to add some wait state in the read or write cycle of that peripheral device, so that both the devices can cope up with each other. So, we have completed all the pins related to microprocessor 8086. Once again, these are address lines which are multiplexed, interrupts, clock, two grounds are there, VCC plus 5 volt, these are higher address lines, BHE, minimum maximum mode and all these signals. So, we have covered all the 40 pins. In the next lecture, I am going to discuss about the operation of 8086 in minimum mode and maximum. Thank you.